Hello and welcome. Today we're going to address the concept of dividing monomials. In previous lessons we talked about finding the greatest common factor of two monomials. Now we're going to start dividing those monomials. Our goal is to lead into factoring polynomials. First, let's recall reducing fractions. In order to do so, we reduce the numerator and the denominator by the greatest common factor of the two. So in order to reduce each of the fractions, we must find what is the greatest common factor of the numerator and the denominator. So what I am going to do is factor 6 and factor 15. For 6, I get 2 times 3. 15, I get 3 times 5. As we can see, the greatest common factor of 6 and 15 is 3. So I can cross out the 3 on the bottom and on the top, and what I'm left with is 2 for my numerator and 5 for the denominator. Again, for 26 and 30, I factor the numerator of 24 to get 2 times 3 times 4 over, when I factor 30, I get 2 times 3 times 5. There are two common factors of 24 and 30. They each have a 2 and they each have a 3. So the greatest common factor of 24 and 30 is 6. When I cross out the 2's and the 3's, what I'm left with is the 4 for my numerator and 5 for the denominator. For 54 and 36, I can factor 54 into 2 times 3 times 3 times 3, while 36 can be factored into 2 times 2 times 3 times 3. My greatest common factor here is 18 because they have a 2 in common, a 3 in common, and another 3 in common. When I multiply 2 times 3 times 3, we get 18. Crossing out the 2's, the 3's, and the other pair of 3's, what I have left with on the top is a 3, and my denominator is a 2. When we reduce monomials that have variables, we are going to repeat a very similar process. I'm going to factor the numerator and factor the denominator and see what I can cancel out. For r over r to the fourth, r is simply r, but r to the fourth is r times r times r times r. Just like in our previous slide, I am going to cross out the common factors. My r's cancel, leaving me with just a 1 on top, and on the bottom I have 3 r's being multiplied, which I can write as r to the third power. Similarly to the right, x to the fourth can be written x times x times x times x, while x to the seventh can be written as x times x times x times x times x times x 7 times. Crossing out the common factors from the numerator to the denominator, I cross out one pair of x's, I cross out the second pair of x's, a third pair, and I cross out this fourth pair. All of these are in common with the numerator and the denominator, so I may cross them out. Well, on the top, I have a 1 since everything canceled, and on the bottom, I have 3 x's being multiplied. I can write that as x to the third power. To the right, again, I can write my y's as y times y times y times y times y, while my denominator is simply 3y's. From the numerator to denominator, when I cancel out, there are 3 y's in common, leaving me with simply y times y on the top of my fraction, or y squared. On the bottom, since everything went away, I do not need to write my denominator. So this reduces down to y squared. Go ahead and take a moment to pause the video and try the next 3 on your own. You should have 1 over p, then v squared, then 1 over m squared. If you haven't noticed, there's a shortcut we can take. In this shortcut, when you have the same base, all you are going to do is subtract the exponents. The remaining variable, or base, will stay on the side of the fraction where the larger exponent was. For example, I can write this out, as we did on the previous slide, as m times m over m times m times m. On the top and the bottom, I have 2 m's in common, so I cancel them out. On the top, since everything canceled, I have a 1, and on the bottom I have an m. What we could do instead is we could say, I have 3 m's on the bottom, and I have 2 on the top. If I subtract these, 3 minus 2 equals 1. So my new exponent on m is going to be a 1. Now look where the larger exponent was, and that was in the denominator of your fraction. So I am going to put this m to the first in the denominator of a fraction, and everything on top went away, so I simply write a 1, which is exactly what we had above, we just went about it in a slightly different way. To the right, first I'm going to go ahead and cancel these 2's out, so I have x over x to the 3rd power. When I subtract my exponents, 3 minus the 1 that's on top gives me 2. Since there are more x's on the bottom, my x to the 2nd power is going to be in the denominator of my fraction, and there is simply a 1 on top since all of my x's cancel. Below to the left, I cannot reduce the 4 and the 3, so I leave my 4 on top and my 3 in the denominator. But my m's, I could write them out and then cancel them, or simply subtract the exponents. M to the 4th on top, m to the 1st on the bottom. 4 minus 1 is 3. Since there are more on the top, my m to the 3rd remains on the top. To the right, I'll go ahead and reduce my 3 and my 6. The 3 in the numerator becomes a 1, and the 6 becomes a 2. And now writing out 22 x's on the top and 18 on the bottom sounds like a lot of work, so I'm just going to subtract my exponents. 22 minus 18 gives me 4. Since there are more on the top, my x to the 4th power remains on the top. That 1 in front is kind of unnecessary, so I'm just going to go ahead and write this as x to the 4th over 2. We will go about these very similarly. I have the same base of 15 on the top and on the bottom. It's just like the previous slides where I had an x as a base, but now I have a number and it's 15. Subtracting the exponents, 70 minus 30 gives me 40. So I end up with 15 to the new exponent of 40. Since there were more 15's on the top that had a greater exponent, my resulting answer will also be in the numerator of my fraction. So on the bottom, since all of those 15's canceled out, I simply have a 1. Now writing the 1 is unnecessary, so I'll just write this as 15 to the 40th power. Down below, it looks a little weird, but this is also the same thing. Your base is now x minus 3, all raised to the 5th power. And in the denominator, your base is x minus 3. It is being raised to the 7th power. When we subtract the exponents, I have 5 on top and 7 on the bottom. Subtracting gives me a new exponent on x minus 3 of 2. Since there are more on the bottom, 7 is greater than 5, my x minus 3 to the 2nd is in the denominator, And in the numerator, since all of those canceled, I just write a 1. Go ahead and take a moment to pause the video and try the next two on your own. You should have 1 over 17 to the power of 15 and 1 over x minus 5 all raised to the 6th power. On this slide, we're going to start putting more ideas together. Instead of just one variable over another, we're going to reduce coefficients, and then we're going to reduce two different variables, but we go about it in the same exact manner. Step 1, I see 6 and 18 can reduce to 1 and 3. So on the top of my fraction, I have a 1. In the denominator, I have a 3. Step 2, I see x's on the top and the bottom. I have 8 on top and 3 on the bottom. Subtracting leaves me with 5 on the top. For my y's, I have 6 on top and 13 on the bottom. Subtracting leaves me with 7, and since there are more on the bottom, my y to the 7th stays on the bottom. Second, I'll reduce my negative 5 to a 1 and my negative 10 to a 2. So in the numerator I have a 1, denominator I have a 2. I have x to the 3rd on top and only x to the 1st on the bottom. Subtracting, 3 minus 1 is 2. Since there are more x's on the top, my x to the 2nd remains in the numerator. My y's, I have y to the 7th over y to the 7th. Those are going to cancel each other out completely, so there are no more y's in my expression. I can rewrite this without the 1, although I did not do that above, to get x to the 2nd over 2. Go ahead and try the next two on your own. You should have 3y to the 7th over 2x to the 3rd, and 5x to the 8th over 2y to the 2nd power. Now for our last slide, we're going to put some ideas together. In previous lessons, we've talked about rules of exponents. When we multiply bases, we add the exponents, versus when you raise an exponent to a power, you multiply the exponents. So what I'm going to do is simplify the numerator and denominator of each fraction before reducing my fractions like I have in this lesson. So step 1, I'm going to multiply my 6 and my negative 4 to get negative 24. I can then multiply my x to the 4th and x to the 3rd by adding the exponents to get x to the 7th. I can multiply my y to the 5th and my y by adding the exponents to get y to the 6th power. My denominator, since there is an exponent on the outside of parentheses, and since there is no addition or subtraction inside, I am going to apply that exponent to every term inside. I end up with 2 to the 3rd, x to the 6th, and y to the 9th, which multiplies out to 8, x to the 6th, y to the 9th. Now that I've simplified the numerator and the denominator separately, I am going to simplify the entire fraction as a whole. Reducing my 24 to a negative 3 and my 8 to a 1, I have a negative 3 in my numerator and a 1 in the denominator. For my x's, I have 7 on top and 6 on the bottom. 7 minus 6 is 1, and since there are more on top, my x to the 1st is on the top. For my y's, I have y to the 9th and y to the 6th on the top. Subtracting, I get y to the 3rd, and since there are more on the bottom, my y to the 3rd is in the denominator. Again, I may write that without the 1 and have negative 3x over y to the 3rd. Second, I may rewrite my numerator as negative 8 x to the 12th over 2x to the 10th. Reducing my 8 and my 2, I get a negative 4 on top and a 1 on the bottom. 12 minus 10 is 2, so I have x to the 2nd on the top, or just negative 4x to the 2nd. Go ahead and try the next two on your own. You may now check your answers, and I hope you have a wonderful rest of the day.